ladies and gentlemen. Today's video is going to be a little laid back, as you can plainly tell from my swanky attire and from these high-class digs I've chosen for my studio. Here's today's topic. Oh wait. Now what I'm going to do is I'm going to solve 3 of these problems directly from the homework assignment. I'm going to go through them step by step. But I'm doing this kind of off the cuff, so it is entirely possible I'll make a mistake. Hey, that happens. I'll do my best. Here's what I promise. If one of my students discovers a mistake that I've made somewhere here in the video and points it out to me, 10 points of extra credit. Let's give it our best shot. We are solving a system of equations using the substitution method. Now I'm going to steal some problems directly out of our homework assignment, but I'm going to spend just a moment first explaining what we're doing. There are 2 equations. Let's say here in this example it's x plus y equals 17. That's the red equation represented on this graph. And there's x plus y equals 7. That's the blue equation represented on this graph. Now there are solutions to the red equation. For example, here's one over here at 10, 7. The x value of 10 and the y value of 7 satisfies the red equation. There are solutions to the blue equation. Here at 3, 10 is a solution to the blue equation. There's a spot at 5, 12 that satisfies both equations. It's the only spot that does that. We found it here easily enough by graphing. I want to do it now using math. And the math we're going to use is the substitution method. What I want to do is take one of the equations and put it inside the other one. Substitute its value into the other equation. The bottom equation is beautifully set up for that. Look, y equals x plus 7. That literally means that y is x plus 7. And if y is x plus 7, then I can write the top equation, x plus y equals 17. Except instead of y, I'll write the value of y from the other equation. So x plus 7 is what goes here. From the top equation, x plus the value of y as demonstrated in the second equation equals 17. Now I have a brand new equation, and you'll notice it has no y in it. By substituting one equation into the other, we got one of the variables to disappear. Now we simplify this equation. This part's just algebra. X plus x makes 2x. There's a 7 here as well. And finally there's the 17. Get the 7 to leave from both sides. You get 2x equals 10. And divide both sides by 2. And we find that x, at least for the moment when both equations are stuck together, has to be 5. That's half of my answer. Now take half that answer and plug it back into either of the original equations. Boy, that second one looks like it's perfectly set up for it, doesn't it? If y equals x plus 7, but we know that x is 5, at least for this moment, add 7 to that and we find that y is 12. There is the solution to both equations. Let's try it again. Here are 2 different equations. They're going to have a different solution and we don't know yet what it is. I could graph it. I could graph it to see whether or not I'm right when I'm done. But for now, let's use substitution to see what that xy point is that satisfies both of them. I'm going to put the top equation inside the bottom one this time. Why? Because the top equation already is defined in terms of one variable. Y is x minus 19. So I'll write the second equation, 2x minus, and then since I know what y is, that's what I'm going to replace. Y is x minus 19 according to the top equation. And the rest of the bottom equation is equals 27. Notice that this is just the bottom equation except the y's been replaced. Also notice I used parentheses and I did it on purpose because we are subtracting y, which means it's minus x and minus 19. When we go distributing that, what we discover is that 2x minus x is the first part, but minus negative 19 actually becomes positive 19. The 2x and the minus x become a total of a single x, plus 19 equals 27. And if I subtract 19 from both sides, boy, this is where my arithmetic is going to come in. I guess that's going to be 8, right? Gosh, I hope so. That means 8 is my x value, and now I'll plug that 8 back into one of the original equations. Boy, that top one looks like the perfect one for it, doesn't it? So y equals 8 minus 19. And again, if my arithmetic is good, 8 minus 19, I think has to be negative 11. Negative 11. So 8 and negative 11 is the magic xy point that satisfies both of these two equations at the same time. All right, one more, and this one looks a little bit tougher. In fact, here's the problem. Neither of these equations is set up with a variable equals, but this y looks like it might be able to get there relatively easy. Before I do anything else, I'm going to have to fix that top equation so it says y equals. Fortunately, that's easy. If I subtract 12x from both sides, then that gets rid of it on this side and puts it over on the other side. That's technically the same thing as simply putting it on the other side and changing its sign. I hope you notice and can see that the top equation now has been rearranged. It's the same equation with the same solution set, only now it's redefined in terms of a variable. Y is negative 12x plus 21. And now that means I'm prepared to write the second equation, 18x minus 3 times, and I'm going to put a big set of parentheses here, y equals negative 36. Only the thing is, I know what y is. It's negative 12x plus 21. Now I am ready to solve this new rewritten equation, substituted in equation, with only one variable in it. It only has x. Now this is going to take a little bit of algebra here. I hope I can keep it straight. 18 minus, let's see, negative 3 times negative 12x makes positive 36x. And negative 3 times positive 21 makes negative 63. And that equals negative 36. The 18x and the 36x together make, let's see, there's a 4, and then that'll carry 1 to the 54x minus 63 equals negative 36. Now I'm going to add 63 to both sides, so I get my variable alone on the left. So 54x equals, what is that, 27? I believe that's 27. 27, okay. I'm not so sure about this, but I bet I'll discover if I divide both sides by 54, which is what it takes to get x alone, that x is 1/2. The value of x is 1/2. Our job now to find the other value, the y value, is to plug this x value into one of these equations. I like the top one because y is going to be nice and simple to solve, so 12 times my magic x value of 1/2 plus y is going to equal 21. Half of 12 is 6. Boy, we were able to kill that fraction easily, weren't we? Plus y equals 21. Subtract 6 from both sides, and we find that y is 15. 15. With any of these problems, if you ever decide that you're not sure about the result, all you have to do is drop those values into Desmos or any other graphing calculator, and it will happily tell you whether or not you found the right spot. You can also take these two values, x and y, and plug them into first the first equation and then the second equation. Both equations should come out happy. If they do, you know you've got the right answer. So that's it. You can solve a system of equations by substitution, putting one of the equations inside the other one and solving for the remaining variable, then using the result of that variable to find the value of the first one. Good luck. Wait till you see elimination. That's next.